Welcome viewers. In the last video lecture, we saw one particular case when we take C value equal to 0. Okay. Now we continue our discussion from there only. Now suppose that we have a Fourier series expansion fx equal to a naught by 2 plus summation n vary from 1 to infinity an into cos nx plus summation n vary from 1 to infinity bn into sin nx. Okay. Suppose that this function is a periodic function in the interval c to c plus 2 pi. Okay. Now the value of a naught, okay, it is given by 1 by pi c to c plus 2 pi f of x into d of x, and an it is given by 1 by pi integral c to c plus 2 pi f of x into cos nx dx, and bn this is equal to 1 by pi c to c plus 2 pi. Okay. fx into sine nx into dx. Okay. So I quickly discuss the case that if I take a c value, okay, equal to 0. Okay, if I set c value equal to 0, then this a naught, this is equal to 1 by pi 0 to 2 pi into f of x into d of x. Okay, and an this is equal to 1 by pi 0 to 2 pi f of x into cos nx dx. Okay, and bn this is equal to 1 by pi 0 to 2 pi f of x into sine nx into dx. Okay, so whenever your interval is 0 to 2 pi, okay, because if you take c value equal to 0, then this interval becomes 0 to 2 pi. So whenever the interval is 0 to 2 pi, in that case we find all these values a naught, an and bn. Okay, so I repeat, whenever the interval is 0 to 2 pi, in that case we always find all these values a naught, an and bn. Okay, and this is called Euler's formula. Okay, so this is the first case when c is equal to 0. Okay, now next we talk about the second case. Okay, case 2. Case 2, when c is equal to minus pi. Okay, in that case you see that your this a naught, it just becomes 1 by pi minus pi to pi f of x into d of x, and this an it is equal to 1 by pi minus pi to pi f of x into cos nx into dx, and bn this is equal to 1 by pi, okay, minus pi to pi f of x into sine nx into dx. Okay, when the c value is minus pi, in that case the interval is minus pi to pi. Okay, now you notice here one thing, that whenever the interval is minus pi to pi, and in that case we calculate a naught, an and bn like this. Okay, but here we note one thing, that if function is neither even, neither even nor odd, find a naught, an and b in those questions. Okay. By that I mean that if your function it is neither even nor odd function, then you find all the values a naught, a n, and b n. But our task gets reduced. Okay. If function is odd function and interval it is minus pi to pi. Okay, so if the interval is minus pi to pi and you check that your function is odd function, then you see as this function is odd, okay, and the integral limit it is minus pi to pi, so a naught it becomes 0. Okay, this is the result of definite integral. Now this function is odd function, okay, and this cos it is an even function. Okay, so odd into even, okay, odd into even, what it is an odd function, so the value of an is also 0. Okay, but as your function it is odd function and sine is also odd, so odd it is odd it is even function. Okay, so as this function is even, so it means that bn does not become 0. Okay, and bn it can be written as you write 2 outside the integral sign and your lower limit becomes 0 here. Okay, 0 to pi f of x into sine x sin nx into dx. So, as only bn survives in case of odd function, so your Fourier series it just reduces to summation and vary from 1 to infinity bn into sine nx. Okay, so we just use this formula only for finding the Fourier series of our function if the function is odd function, and a naught and an they are taken as 0, and we just find the value of bn using this formula 2 by pi 0 to pi f of x into sine nx dx. Okay, now next we want to talk about if this is case 2, if function is even function and interval is minus pi to pi. Okay, if function is even function and the interval is minus pi to pi, you see that as the function is even function, so this a naught, okay, this as it is an even function, so it does not become 0. So the value of a naught is 2 by pi 0 to pi f of x into d of x. Okay, and this function is an even function, this cos is also even, so even it is even, so an also does not become 0 in this case. Okay, so as as an it does not become 0, so we can write it like this, that an this is equal to 2 by pi 0 to pi f of x into cos nx into dx. Okay, and what is bn? Okay, you see here bn, as your function is an even function, so this function it is even and this function it is odd, so product of odd and even is what it is odd, so the value of integral is 0. Okay, so the bn it is 0 in this case. Okay, so as the bn is 0, so it means that in this case our Fourier series, okay, it is just reduces to a naught by 2 plus plus summation, and I write it once again. Our Fourier series it reduces to fx equal to a naught by 2 plus summation n equal to 1 to infinity an into cos nx only. Okay, and using these formulae we can find the value of a naught and an. Okay, see, this is done only in the case when the interval is minus pi to pi. In the interval 0 to 2 pi, we need to find all the values a naught, an and bn. Okay, but only in the interval when you have minus pi to pi, you need to check that your function is even function or odd function. If it is an even function, then only bn becomes 0 and we find the value of a naught an. And if the function it is an odd function, in that case we take a naught and an as 0 and we find the value of bn. Okay, so we now solve some questions. So questions of this, they are very easy. So question number 1, find the Fourier series. Find the Fourier series expansion of fx equal to x in the interval minus pi to pi. Okay. Now you see that fx equal to x. This function is an odd function. Okay, and the interval is minus pi to pi. Okay. So solution, as f of x is an odd function, therefore a naught and an, okay, they are equal to 0. They are equal to 0. So our Fourier series expansion, it now becomes summation n vary from 1 to infinity bn into sin nx. Okay, so this is the Fourier series expansion. Now we want to find the value of bn. So what is bn? Bn is equal to 2 by pi, okay, 0 to pi, okay, into fx into sin nx. Okay, why we are doing like this? Because this function it is an odd function, and in case of odd function, this function is odd and sign is also odd. So here we write 2 outside the integration sign and the lower limit becomes 0. So this is equal to 2 by pi 0 to pi. Okay, what is the function? Function is x into sin nx into dx. Okay, now apply u into v. Okay, apply u into v. So what is u into v? U into v without using integration sign. Okay, so it is u mean x integration of this function. Integration of sin is minus cos nx by n minus derivative of x is what it is 1. Integration of minus sin is minus integration of minus cos is sorry minus sin nx by n square. Okay, within the limit 0 to pi. Okay, so this is equal to 2 by pi minus x into cos nx by n minus minus plus sin nx upon n square within the limit 0 to 1. Okay, 0 to pi, sorry, within the limit 0 to pi. Now wherever you have x, there you put pi. Okay, so you see that what do you get here? Put x equal to pi here, so it is minus pi into cos n pi, okay, divided by n. Put x equal to pi here, so sin n pi it is 0. Put x equal to 0 here, so this is 0. Put x equal to 0 here, sin 0 is 0. So you are left with this thing only. Okay, So it is what? It is minus 2. And cos n pi is minus 1 raised to the power n divided by n. So this is the value of Bn. Okay. So after finding the value of Bn, we write it in our Fourier series. Okay. So f of x, this is equal to summation n equal to 1 to infinity Bn into sine nx. Okay. So what is the value of Bn? Bn value, it is minus 2 into minus 1 raised to the power n divided by n into sine nx. Okay. So this is the Fourier series expansion for our function. Okay. Now next we solve one more question, and the question is this, that find the Fourier series expansion. Question is this, that find the Fourier series expansion. Find Fourier series expansion of f of x equal to x square in the interval minus pi to pi. Okay. So solution, as f of x, this is equal to x square. Okay. Uh, okay, and this function is an even function. So as it is even function, so the value of Bn is 0. Okay. Value of Bn is 0. Now, so the Fourier series expansion of this then becomes fx equal to a naught by 2 plus summation n equal to 1 to infinity an into cos nx. Okay. Now we would like to find the value of a naught and an. Okay. So what is the formula for finding a naught? A naught, this is equal to 1 by pi minus pi to pi. Okay. F of x into d of x. Okay. So it is 1 by pi minus pi to pi. What is the function here is x here into dx. But see here, this function is an even function. Okay. So what is the result of definite integral? If the function inside the integral sign is even function, so you write 2 outside the integral sign, and the lower limit becomes 0. So it is 0 to pi x square into dx. Okay. Now what is the integration of x? Integration of x square is x raised to the power 3 by 3 within the limit 0 to pi. Okay. Now wherever you have x, there you put pi. Okay, there you put pi. So pi cube by pi. So what it is? It is 2 by 3 pi square. So this is the value of a naught. Okay, this is the value of a naught. Now next we want to find the value of an. Okay. So the formula, as this function is even function, so you can directly write here 2 by pi integration 0 to pi. Okay, x square into cos nx into dx. Now apply here u into v rule. So what is u into v rule? U into v rule is u integration of v. Integration of cos is sine nx by n. Okay, minus derivative of x square is 2x. Integration of sine is minus cos nx upon n square plus derivative of 2x is 2. Okay, and then integration of this function, which is minus sine nx by n cube. Okay, within the limit 0 to 1. Okay. Now first of all, you adjust all the negative signs. Okay, negative and positive signs. Okay, So it is x square into sine nx by n. Okay. So negative negative, it is what it is positive. So it is 2x into cos nx by n square. Okay. Then minus 2 sine nx upon n cube. Okay. Within the limit 0 to pi. Okay. Now what you do, you put the limits. Okay. When you put here x equal to pi, you see what you get here sine n pi. So sine n pi is 0. Okay. Then you put x value equal to pi in this. So it becomes 2 pi into cos n pi by n square. Put x value equal to pi here. So sine n pi it is 0. Now put x value equal to 0 in this. Because of this x it becomes 0. Put x value equal to 0 in this. This then becomes 0. Put x value in this. So sine 0 is 0. Okay. So here you are left with this. So 2 into 2 is what it is 4. And cos n pi is what it is minus 1 raised to the power n divided by n square. Okay. Now after finding the values of a naught and a n, you substitute these values in equation number 1. So f of x, this is equal to a naught by 2. See, your